The story of artificial intelligence doesn't just unfold in dramatic leaps. It's a tale of steady progress, breakthroughs, and the brilliant minds that dared to believe machines could not only compute, but reason, plan, and solve problems. From the pioneering work of Alan Turing, which laid the theoretical foundation, AI began to emerge as a tangible field of study in the mid-20th century. But how did we get from Turing's abstract ideas to the practical systems that began shaping the world of AI? To answer that, we need to explore the early milestones, when AI first took its tentative steps and evolved through symbolic reasoning, problem-solving, and expert systems. These milestones didn't just advance technology, they changed how we think about intelligence itself. Let's step into the mid-1950s. This was an era of post-war optimism, where technological innovation was reshaping industries and society. It was also the time when the term artificial intelligence was born. In 1956, a small group of researchers gathered at Dartmouth College in New Hampshire for a summer workshop that would go down in history as the birth of AI as a formal field. The Dartmouth Conference was the brainchild of computer scientist John McCarthy, who envisioned a future where machines could replicate human thought processes. The researchers at Dartmouth believed that machines could be taught to reason symbolically, like humans. Symbolic reasoning, what we now call symbolic AI, was based on the idea that intelligence could be represented using symbols and rules. Think of symbols as building blocks, numbers, letters, or words that represent concepts, and rules as the glue that binds them into logical relationships. One of the first great milestones in symbolic AI came just a year after the Dartmouth Conference. In 1957, Alan Newell and Herbert A. Simon developed the logic theorist. This program was designed to mimic human problem-solving by proving mathematical theorems. What made the logic theorist so remarkable was that it didn't just perform calculations, it reasoned. It was capable of discovering new proofs for theorems, sometimes more elegantly than those devised by humans. The logic theorist demonstrated that machines could not only process information, but could also engage in creative problem-solving. This was a radical departure from the purely mechanical machines of the past. It marked the first step toward building systems that could think abstractly. By the early 1960s, the field of AI was gaining momentum. Researchers were developing programs that could play games, solve puzzles, and even engage in basic conversation. One notable achievement during this period was IBM's creation of a program called the General Problem Solver, or GPS. Developed by the same team behind the logic theorist, GPS was a more ambitious attempt to create a universal problem-solving machine. Unlike earlier systems, GPS wasn't limited to solving specific problems. Instead, it was designed to tackle a wide range of tasks using a general set of strategies. While it was far from perfect and often struggled with complex problems, GPS was an important step in advancing the idea that machines could be flexible and adaptable. The optimism in the field during these early decades was electric. Many researchers believed that the development of human-level intelligence was just around the corner. But as the 1970s approached, the AI community began to encounter some hard truths. Despite their symbolic reasoning capabilities, these early systems struggled with the complexities of real-world problems. They were brittle, meaning they worked well in narrow, predefined scenarios, but failed when faced with uncertainty or ambiguity. This period, sometimes called the AI winter, brought funding cuts and skepticism. Critics argued that AI had overpromised and underdelivered. But while progress slowed, it didn't stop. During this time, an important shift occurred. Researchers began to focus on domain-specific knowledge. Instead of trying to create machines with broad human-like intelligence, they started building systems that could perform at an expert level in specialized fields. These systems became known as expert systems. Expert systems represented a new paradigm in AI. They combined symbolic reasoning with a deep knowledge base in a specific area, such as medicine, engineering, or finance. The goal was not to mimic general human intelligence, but to replicate the decision-making capabilities of a human expert. One of the most famous expert systems was developed in the early 1970s at Stanford University. It was called Mice-In, and its purpose was to assist doctors in diagnosing bacterial infections and recommending treatments. Mycin worked by using a knowledge base of medical facts and a set of rules to analyze patient data. While it didn't replace doctors, it provided valuable insights that improved patient care. What made expert systems like Mycin groundbreaking was their ability to make decisions based on logic and reasoning, much like a human expert would. They showed that AI didn't need to replicate the full spectrum of human intelligence to be useful. Instead, it could excel in specific domains where deep expertise was required. By the 1980s, expert systems were being adopted in industries around the world. They were used to diagnose equipment failures, optimize supply chains, and even manage financial portfolios. This era marked a shift from AI as a theoretical endeavor to AI as a practical tool with real-world applications. However, expert systems had their limitations. They relied on manually encoded rules and knowledge, which made them difficult to scale or adapt to new domains. They also struggled with uncertainty, as they lacked the ability to learn from experience. This led researchers to explore new approaches to AI, approaches that would eventually lead to the development of machine learning and neural networks. Looking back, the journey from symbolic AI to expert systems represents a crucial chapter in the history of artificial intelligence. It's a story of ambition, innovation, and adaptation. These early milestones laid the groundwork for the AI systems we use today, from recommendation algorithms to virtual assistants. Symbolic AI taught us that intelligence could be represented in symbols and rules, while expert systems showed us the value of domain-specific knowledge. Both approaches expanded our understanding of what machines could do and set the stage for the next wave of AI innovation. As we move forward in exploring AI's history, we'll see how these early ideas evolved into the powerful, learning-driven systems of today. But for now, let's take a moment to appreciate the pioneers of symbolic AI and expert systems, visionaries who dared to believe that machines could think, reason, and solve problems in ways that once seemed impossible.